Is there a place beyond Earth that could become a home for future Earthlings? This is one of the most important questions facing humanity. You probably know about the many programs aimed at searching for Earth-like exoplanets that could potentially shelter humanity in the future. But did you know that such a planet might be much closer than we think and is located in the solar system? And no, I'm not talking about Mars, and you can't really call this potential new Earth a planet because it's just a moon. I'm talking about Titan, Saturn's moon, the only moon in the solar system that has a dense atmosphere and a rather diverse landscape crossed by rivers and lakes. So what is this object, and why is it of interest to people on Earth? Is it possible that colonizing Titan isn't science fiction at all, but a very real prospect for humanity? What do we know about Titan? Actually, quite a lot. Titan is one of those objects that we've known about for many centuries. The moon was discovered back in 1655 by the Dutch astronomer Christian Huygens, who was inspired by the work of Galileo Galilei. For about 2 centuries, it remained nameless until 1847 when John Herschel finally gave it a name. So what exactly is this mysterious moon of the giant planet? Is it more like a planet itself? Titan is quite large. It's bigger than Mercury, although it has less mass. If you compare Titan to the moon, its radius is about 50% larger, it's 3.24 times bigger in volume, and it's 80% heavier than our nightlight. Gravity on Titan is 7 times weaker than on Earth, but Titan's uniqueness isn't in its size, but in its dense and extensive atmosphere, which is almost 4 times denser than Earth's and more than 400 kilometers thick. This makes Titan the only moon in the solar system with such a significant atmosphere. Moreover, its composition is quite similar to Earth's, because the main element that makes up Titan's atmosphere is nitrogen, which accounts for about 95%. The first spacecraft to fly by Titan was Pioneer 11, whose mission was to study Saturn and Jupiter. This happened in 1979. A year later, the Voyager spacecraft came even closer to the moon. Several pictures were taken by the spacecraft, but they turned out to be too blurry to make out any details. A little more light was shed on what Titan's surface looks like by the Hubble telescope in the 1990s. It was the images taken by it that indicated that the orange color of the moon is due to the methane smog surrounding it, which made it possible to see the terrain only approximately. What Titan looks like on the surface beneath the blanket of methane haze remained a mystery for many years, but everything changed when National Aeronautics and Space Administration launched the Cassini spacecraft, whose mission was to explore Saturn and its moons. The spacecraft carried the Huygens probe on board, and on January 14, 2005, it made a successful landing on Titan. What did scientists observe in the images from the surface? They truly witnessed a fantastic sight. Titan turned out to be more similar to Earth than anyone could have imagined. It's the only object in the solar system besides our planet whose surface is covered with rivers, seas, and lakes. Moreover, the cycle of liquid on Titan happens just like it does on Earth. The contents of the bodies of water evaporate and then return to the surface as precipitation. Don't get too excited. Subtitles by Dima Torzak. Although Titan is similar to Earth, when you look at it, it brings to mind rather eerie images of post-apocalypse. A barren rocky landscape, orange fog, and rivers made not of water, but of liquefied methane. It is methane rain that scientists believe falls on Titan. There is no oxygen in the atmosphere, of course, but that's not even the worst part. What is the temperature on Titan? Unfortunately, it's the least suitable for humans. On the surface of the satellite, the temperature is about minus 179 degrees Celsius. And it's so low that the ice, which is abundant on Titan, is more like stone in structure. And in some areas, there are cryovolcanoes that erupt water, ammonia, and methane from their depths. As you can see, the conditions on Titan are quite harsh and deadly for humans, even though the moon has some external similarities to Earth. You definitely wouldn't want to pack your bags and move there tomorrow. But why is the exploration and colonization of Titan so tempting for Earth scientists? Maybe things on Titan aren't so bad. What is the potential of this moon, and why is it of interest to Earth? To begin with, Huygens, which landed on Titan and sent back images, became a real-time machine for people on Earth. After all, Titan is almost identical to the young Earth. Our planet was almost the same before the first organic life appeared on it. Did you know that the Earth's atmosphere didn't become saturated right away, but only as a result of active photosynthesis by developing flora? Back when Earth was completely lifeless, its atmosphere was completely different. Yes, Titan is much colder than Earth, but that doesn't rule out the possibility that the first life might already be emerging in Titan's lakes, because its forms could be completely different from those on Earth. Imagine the incredible opportunity scientists have to explore our past and solve one of the universe's biggest mysteries, the origin of life on Earth. But is pure scientific interest the only goal that humanity can pursue on Titan? Not at all. There are simpler and more important goals, such as, for example, obtaining valuable fuel. The satellite is rich in hydrocarbons, which are the preferred fuel on Earth, and in the context of the constant depletion of our planet's resources, this is a real gold mine. Rivers and lakes of methane and ethane on the satellite could serve as raw materials for rocket fuel. And Titan's atmosphere, despite all its drawbacks, also has huge advantages. On one hand, the reduced gravity will make it easy to transport cargo. On the other hand, the atmosphere, which is almost 4 times denser than Earth's, could be very effective for wind power plants and generating electricity. A scientific review, the Space Monitor notes that Titan is a place where people could survive quite well, despite all the difficulties. Oxygen can be generated artificially, and hydrocarbons can be used by the colony to sustain its life. Methane, nitrogen, and ammonia can become excellent raw materials for fertilizers, which will be needed to grow plant food. Titan could effectively become the center of the world economy. If the development of thermonuclear energy ever reaches a high level, there will be a strong need for deuterium and helium-3, which are extremely scarce on Earth, but are found in large quantities on Saturn. And Titan could become a kind of transshipment point for the extraction and transportation of these substances. Just imagine the level humanity could reach if it gained the ability to extract the resources it needs from other planets. It really sounds like science fiction. It's no wonder that the colonization of Titan has become the plot of many works of fiction, movies, and books, inspiring science fiction writers from the mid-20th century to this day. The idea that our potential new home could be right nearby within the solar system and not on distant, mysterious exoplanets is certainly very exciting and inspiring. But is it really that simple? What challenges might the colonists face? Of course, the first things that come to mind are the low temperatures and the toxic, unbreathable atmosphere. But while this problem can be solved by building domes, using protective suits, and generating oxygen, the low gravity could play a nasty trick on the colonists. On one hand, it will make everyday life and movement easier, but on the other hand, it will inevitably cause major health problems. Muscles will rapidly lose strength and mass, and bones will become weaker. The colonists will literally have to spend hours doing intense physical exercise, otherwise their bodies will rapidly weaken and age. But what about water? We need it to survive, and unfortunately, we can't drink liquid methane. There is an opinion that Titan has water in the form of a subsurface ocean, but it contains so many salts that it's unsuitable for humans. Theoretically, water can be extracted from the solidified ice, which is abundant on Titan's surface. But this would require building a large number of nuclear reactors. It's even scary to think about how much such experiments could cost. Dr. Robert Bassert calculated that a mission to Titan with 400 people provided with everything necessary for life, and its further support and supply would cost about $16 billion a year. But the biggest challenge isn't money or resources, it's the distance. With today's level of space industry development, a journey to Titan would take about 7 years. This makes a colonization mission extremely difficult to carry out, since the distance between Earth and Titan is 1.2 billion kilometers. That's why, even though Titan is much more interesting and promising, colonizing Mars seems much more realistic in the coming years, since the distance to Mars is, no more and no less, 21 times shorter. Nevertheless, scientists are full of enthusiasm, and in the coming decades, people on Earth have many plans for further exploration of Titan. For example, by 2027, the launch of Dragonfly is planned, a mission that aims to land a unique flying vehicle on Titan. Its goal is to search for traces of abiogenesis, the transformation of non-living to living matter, and areas most suitable for life. Considering the 7 years it will take the spacecraft to reach Titan, we will have to wait about 15 years for the results of the mission. But Hubble will try to make this wait easier for you. Neutron stars are the densest structured objects in the universe, except for black holes. In their cores, it is believed you can find the most dangerous substance in the history of the universe, strange matter. And strangely, this substance, not just because of its name, strange matter, breaks the laws of the universe and is even capable of destroying everything that comes into contact with it. What a nightmare, you might say, but that's not entirely the case. This amazing matter, among other things, is capable of revealing a lot about the history of the universe, about its earliest stages. To understand just how incredible this strange matter seems, we first need to grasp a few basic facts about it. So what is a neutron star, and how does strange matter break the laws of the universe? A neutron star is the remnant of a giant supernova explosion. The core of the star collapses under its own increasing gravity with such force that it compresses all the particles inside itself. Electrons collide with protons and turn into neutrons. All the emptiness inside atoms is suddenly filled with particles that aren't actually very happy to be in each other's company, but they have no choice. They desperately push in the opposite direction of gravity, resisting collapse with all their might. If gravity wins, then meet the new black star. If the particles win, a neutron star appears. Because of this, neutron stars resemble giant atomic nuclei, the size of a city but with the mass of our sun. Imagine that a single spoonful of neutron matter on Earth would weigh more than all the matter that makes up the moon. This is where things start to get strange. The conditions in the core of a neutron star are so unusual that the laws of nuclear physics change drastically there. These conditions can lead to the emergence of a strange and dangerous substance. But let's not get ahead of ourselves. First, we need to remind ourselves of the laws themselves before figuring out how to break them. Protons and neutrons are particles that make up the atomic nucleus. They, in turn, are made up of even smaller particles called quarks. They love solitude. You can try to separate them, but the harder you pull, the stronger they will be attracted to each other. If you spend a lot of energy to separate them, they'll just steal it and use it to create new quarks. Quarks exist only as building blocks for other particles and have never been considered on their own. They have amusing names: up, down, strange, charm, beauty, and truth. But only two of them are capable of creating stable matter. Up and down, quarks. All the other variations decay quickly. But this rule may not apply inside neutron stars. The forces at work in the cores of these stars are so extreme that they resemble the processes that took place in the universe right after the Big Bang. So, understanding the rules by which quarks exist inside neutron stars is a way to dive into the history of the universe and a chance to better understand its ancient nature. According to one theory, inside a neutron star's core, protons and neutrons break down, turning into a mass of quarks. A colossal number of particles transform into a single object made entirely of quarks. This kind of matter is called quark matter. A star made of it is called a quark star. The idea of quark stars was developed in a 1970 note by Toshiaki Ito. And in 1971, Arnold Badmer showed the possibility of the existence of strange quark matter made up of three types of quarks. This idea gained particular popularity after the publication of Edward Witten's 1984 article about quark nuggets, clumps of invisible quark matter. According to Witten, such nuggets, also called strangelets, could have remained in the universe after the Big Bang and formed dark matter. And by coming together under the influence of gravity, they could have formed quark stars. From the outside, such stars may be almost indistinguishable from an ordinary neutron star. Now we can talk about that very dangerous substance. If the pressure inside a quark star becomes strong enough, strange things start to happen. In the cores of neutron stars, some quarks turn into strange versions of themselves. They are much heavier and stronger than their ordinary counterparts. Their mass makes up strange matter. It is this, many scientists believe, that could be an example of the perfect substance, perfect density, absolute stability, and indestructibility. This matter is so stable that it can exist outside of a star, and that's a problem. Perfection is contagious, so any other matter that comes into contact with strange matter will try to match it, turning into strange matter itself. The protons and neutrons that make up you and me will start to break down, joining the mass of strange quarks. The only way to escape this disaster would be to throw this matter into a black hole. You might think, why worry if all these quarks are inside a neutron star? But what if one such star collides with another? Before collapsing, they will eject an incredible amount of their contents, including tiny particles of this very strange matter, which are commonly called strangelets, that is, a strange droplet. These particles are capable of traveling vast distances until they encounter a random star or planet. After the collision, the particle will instantly begin turning everything around it into itself. The collision of a strangelet with the nucleus of some atom can cause it to turn into strange matter, which is accompanied by the release of energy. As a result, new strangelets fly off in all directions, which could theoretically lead to a chain reaction. The Large Hadron Collider, a source of pride for humanity and a particle accelerator, was the best advertisement for the strangelet. Let me remind you that this accelerator began operating in 2008 with scientists from over 100 countries, including Russia. Such a grand project could not help but attract the attention of those who are convinced that the experiments taking place there could even threaten the very existence of life on Earth. Supporters of the worst-case scenario have long believed that the killer strangelet would be born there, not come from outer space. One immediately recalls the immortal novel by American writer Kurt Vonnegut, Cat's Cradle, where all the water on Earth turns into Ice 9 under the influence of a fictional substance. Fortunately for us, and unfortunately for the pessimists, the results of many years of experiments show that no stable strangelets are formed as a result of the collider's operation. Let's return to the cosmic visitor. Imagine that instead of a random planet in the path of a strangelay, it's Earth that's there. Its mass would catastrophically decrease, and everything living and non-living on it would merge into one huge mass of strange matter. If a strangelet collides with our sun, its size won't decrease much, but its brightness will drastically drop, and Earth will simply freeze. Thus, at the current level of technological progress, humanity simply has no way to predict, let alone prevent, the moment of a possible catastrophe. A terrifying prospect. But there is another theory, according to which strange matter, particles are a common occurrence in the universe. They don't cause harm, but rather on the contrary, they actually helped expand the universe in its early days. It is possible that strange matter is the very force that holds entire galaxies together. Jing Junjin and his colleagues from Nanjing University believe that they have discovered strange planets made of hypothetical strange matter. Their paper has been accepted for publication in the Astrophysical Journal. On average, the planets we know have a density of about 30 grams per cubic centimeter, but those made of strange matter should be 1 trillion times denser. Such incredible density allows them to survive even when they are extremely close to a similar strange star, and to orbit just a few dozen kilometers from its surface without being torn apart by the power of tidal forces. Is it possible to evacuate the entire population of the planet, Earth? A great disaster is striking Earth, a common trope in science fiction novels and movies. Most often in these stories, humanity is unprepared for the cataclysm and becomes extinct, or is forced to survive in post-apocalyptic conditions. Much less often, people manage to invent an ark capable of saving representatives of our civilization. But is such salvation even possible? How can we evacuate Earth, and where could we go? Can we save all the people on Earth, or will we have to choose the best? Currently, 7.9 billion people live on this planet. We can be sure that the population of Earth will continue to grow steadily. According to the United Nations Foundation's estimate, by 2037, the population will have grown to 9 billion. We are used to seeing spacecraft that can carry relatively small cargo and crews, consisting of only a few people, into space. Will engines in the future be able to lift a ship several kilometers long, capable of carrying thousands of people, into the air? After all, where will we send these arks? Where else in the universe can we find conditions like ours? Even now, we understand that Earth will not always be suitable for life. In about 2 billion years, the expanding sun will boil our oceans, literally scorching all life on the surface. There is the so-called New Pangea theory, according to which all of Earth's continents are steadily moving toward forming a single supercontinent. We don't notice this in our daily lives, but after many generations, life here may change beyond recognition. Climate scientist Paul Valdez from the University of Bristol believes that life on the future supercontinent will be far from easy. Terrible earthquakes, volcanic activity, tsunamis, and asteroids, all of these will continue to threaten humanity. However, the chance of being wiped out by these disasters is much lower than being erased from Earth by a devastating hurricane. Just imagine a wind powerful enough to destroy the strongest and most protected skyscraper. Doesn't that scare you? If the supercontinent forms during a period when volcanic activity has ended, there will be a high concentration of carbon dioxide in the atmosphere. As a result, global warming will intensify to such an extent that it will heat up the world's oceans. And we risk ending up with a world ravaged by hyper-powerful tropical cyclones, 50% stronger than the worst ones in our history. Hurricane Irma is classified as Category 5 in terms of damage measurement. By the way, that's considered the highest category. The wind speed within it reached 285 kilometers per hour, and the northern coast of Cuba was hit by waves up to 11 meters high. Then, a state of emergency was declared in Florida. The entire state was gripped by a natural disaster, and millions of people were evacuated. As a result of the disaster, the economic damage reached more than $77 billion. Now make this nightmare 1.5 times worse. Wind, waves, destruction. And all of this will be happening on Neopangaea all the time. Moreover, there's a pretty big chance of colliding with an asteroid up to 2,000 kilometers in diameter. It's believed that the chance of colliding with such a monster is possible at least once every 300,000 years. Do you think we'll get lucky here too? Humanity is already facing global epidemics that claim not hundreds or thousands of lives, but millions. We'll find a vaccine? The World Wildlife Fund doesn't think so. By 2030, according to their estimates, we'll be consuming natural resources equivalent to 2 planets every year. We may not vanish due to a contagious disease, but rather by consuming our own home. If we are already talking about the human factor, we've completely forgotten about nuclear, chemical, and bacteriological weapons. Here's an example to show why this problem matters. In 2005, the then National Aeronautics and Space Administration Administrator, Michael Griffin, described the goals of the National Space Program. If we, as humans, want to survive for hundreds of thousands or millions of years, we must eventually settle other planets, he said. As we can see, important people have long recognized the inevitability of the global migration of humanity. It turns out that we are ready for this evacuation right now. Unfortunately, in practice, things are very complicated. With our current level of technology, we would need about 750 million modern rockets to get everyone off Earth, plus the equipment, supplies, and other flora and fauna. Manufacturing and launching that many rockets would take millions of years. And what about the direction, where to fly? Naturally, we need a habitat as similar to Earth's as possible. The presence of water is one of the parameters. Outer space is essentially a vacuum, where there is no matter between planets and stars. Liquid water is impossible in such an environment, but besides Earth, there are many places where liquid water is actually possible, such as several moons of Jupiter and Saturn, as well as Mars and Venus in the distant past. Soon, we may discover its significance there. Right now, we don't have a reliable way to synthesize water, but theoretically, artificial water could solve one of the problems of colonization. Space is full of dangers. It's filled with hazardous radiation, both from our sun and from beyond the solar system. Without proper protection, this radiation can harm us and even destroy the living cells in our bodies. Shielding can be made from dense barriers, hydrogen-rich materials, or magnetic fields. Earth naturally provides both a dense atmosphere and a global magnetic field. It is our natural protection against the horrors of cosmic radiation. There are also problems with gravity. Our bodies evolved in Earth's gravitational field. In outer space, far from massive bodies, gravity is relatively weak. This will definitely harm our muscles and bones. Our bones will lose mass and strength, and major muscle groups will atrophy. Certainly, the only solution will be to build closed systems. However, here we have a choice, either to build them in open space or on the surface of other worlds. Is it difficult to build a station in space? Absolutely. Just imagine delivering construction materials, cargo, and people. National Aeronautics and Space Administration's expenses for maintaining the International Space Station from 1994 to 2005 amounted to $25.6 billion United States dollars. And that's with a crew capacity of only 7 people, but we want to save the population of an entire planet. Theoretically, if we could build a self-sustaining, closed ecological system in space, then we could do the same on the surface of the moon or any other planet. One of the advantages of this approach is easier access to raw materials such as water and minerals, which may be located either on the surface or beneath the surface of the planet. The moon is the closest option where such a habitat can be built. Frozen water is hidden in permanent shadow at the bottom of craters, common at the moon's poles. In addition, there's Mars as another option for a surface habitat. People can live in artificial habitats on Mars comfortably and, in theory, indefinitely. But some have held the idea of trying to transform the Martian environment into something more like what it was billions of years ago, to more closely match the conditions on Earth. This process is called terraforming. How did they plan to do it? By massive nuclear bombardment of the surface of the red planet. The detailed properties of these planets have not yet been fully determined. No one knows if they can support human life, but it has been estimated that there may be about 40 billion Earth-like worlds in our universe. The problem is the distance. The nearest potentially habitable exoplanet orbits Proxima Centauri, the closest star to our Sun. This system is 4.25 light years away. At present, we cannot build a single spacecraft capable of reaching speeds close to the speed of light. The fastest spacecraft we have ever built traveled at a speed of about 253,000 kilometers per hour. At that speed, it would take 18,170 years to reach Proxima Centauri. Of course, we imagine panoramas of a distant future for humanity, where we learn to overcome gigantic cosmic distances, build colossal structures in space, and even change the composition of entire planets' atmospheres. By the most approximate estimates, it will take people at least thousands more years to get even a little closer to these dreams. But who decided that we have been given such a long time? And what do you think? Will humanity outlive its home, or will it stop and remain its eternal prisoner? Take a look at the screenshots on the screen right now. This is statistics from YouTube. What does it mean? Notice that right now, 57% of this channel's viewers are watching without subscribing. This is the true essence of my message to you. So, in order not to miss cable among your subscriptions, all you need to do is click on this red button that looks like this and is located below this video. The law of the universe is simple. Remember this, after all, each of your subscriptions is very important. The more viewers there are, the more often they watch, and the faster a new mega exciting video comes out. Talk to you soon.